We will get started with the first talk. Let me share just a couple of things about our first speaker. So Johnny is a solution architect with the Clickhouse team, and he works across users from APAC region with a background in solutions engineering. He's experienced in um, architecting and enabling solutions for enterprise clients. Johnny has a high level of expertise of integration between both public cloud as well as on-premise infrastructure. And he focuses on service assurance, monitoring platforms, and in general, open source technology. We are so happy to host you, Johnny. Over to you.
Thank you, Shiv. Thank you, everybody, for turning up today on a Saturday. Really appreciate your time and coming in to talk about ClickHouse and to meet everyone here. I'm really excited to be here to talk about my journey and how ClickHouse has been just such a great product for me to work on, and enjoying working on several customers a lot in this room today as well. Some interesting use cases. So today, there was a show of hands earlier, and there are quite a few people that are a little bit new to ClickHouse. So I thought we might go through a little bit of a ClickHouse overview as well, but we can get very technical around some of those questions around joins and deduplication and so forth. So a little bit about me. My name is Johnny Mirza. I don't know if I'm related to a famous Indian actress or tennis player or not, but I could be. But that is my background, Johnny Mirza. I am a solutions architect. I'm quite new to ClickHouse, 3 or 4 months into ClickHouse, but have come from a very strong Kafka background. Shiv mentioned Pulsar as well. One thing I wanted to touch on later on, Kafka is great. Also, just the Kafka protocol itself, whether it's Pulsar, Red Panda, the other sort of Kafka protocols. So that's kind of my background in that solutions architecture space. Also come from a background working with telecommunications companies. So lots of RAN data, lots of 4G, 5G type of data, lots of IoT type, really big data coming through Kafka essentially in ClickHouse as well. So lots of big data systems. That's kind of my background. Prior to that, I was working at Splunk as well as a IT ops sort of solutions architect, specialized in that space as well. So now at ClickHouse and absolutely enjoying myself in this space. So what is ClickHouse? I'm just going to start with this slide and really point out what is ClickHouse, just for the new people in the room. So ClickHouse is an open source database created back to solve a problem around clickstream analytics. There's lots of clickstreams, lots of analytics, lots of activity that happens on websites. And when ClickHouse was created, there wasn't an OLAP database. Of course, OLAP has been around for a long time, but there wasn't an OLAP database that was able to handle the throughput that was required to run real-time analytics on top of that, that search. So that's where it's founded, right? It's actually called Clickstream Data Warehouse. If you didn't know that, that's where the name ClickHouse came from. It's actually a Clickstream Data Warehouse. It is the fastest growing database. It's been phenomenal, the growth that we've seen. And the one thing I wanted to mention is ClickHouse as an open source product, but there's also a company behind ClickHouse that have released a cloud version. And we'll talk about what the ClickHouse cloud version looks like. It's a little bit different to the self-managed version. It was only released in 2023, so sort of the end of 2023. So this concept of OLAP is really around column orientated. And the way ClickHouse handles columns is a little bit different. So basically what happens is every single column gets its own file. So if you can think about that within the file system, it gets its own file. So every single row will have its own columns will have its own file within there. It's optimal for aggregations, doing group bys, running searches. There's some trade-offs when we talk about joins and we talk about duplications. There are definitely some trade-offs to having a column-based architecture. We've got some solutions for that as well. It's fast for things like group bys, for example. It's also great for inserting data. So if you think about an insert for a traditional database would have to insert every single row. With ClickHouse, it's broken down per column. So every single insert will have its own file for every column that it needs to write into it. So it makes it super fast to write that data or that block of data into its own column. As most of you know, ClickHouse is distributed. So typically you start off with one server and it gets really big and it starts to throw lots of big data in this one big database. But then you start to distribute ClickHouse out. where you have multiple shards running across multiple servers. I think the biggest server that we've seen is about 4,000 ClickHouse servers. I don't know who it is. Could be eBay or someone big like that, but it's around 4,000 servers running in a big cluster. So it's quite big. And then obviously there's replication that occurs. All of the replications when you're writing, whether you're writing to a distributed table, you're writing to a sort of an individual table, all of that replication happens sort of asynchronously, but very fast as well across all of those different shards and clusters. Yeah, the other really good advantage to ClickHouse when you look at a distributed architecture is being able to run across multi-region. So not only multi-data center, but running across AWS and GCP, for example, and having a single cluster span across multi-region. So last thing, just want to touch on OLAP. It has been around for a long time. OLAP is really made for analytical workloads. It is not made for transactional workloads. We get a lot of questions around updates and deduplication and all those sort of things. It's really like an event sourcing type database. It's very similar to Kafka. It's meant to stream all of the data in. It's meant to provide aggregations across lots of data across a huge set of time. And that's why ClickHouse is so powerful. It's really, really good to do that. Okay, so just a quick little demonstration, if this works. Screenshot, okay. Did it play? That's supposed to play a little video, but it's not doing it. I don't know why. Yeah, okay. All right, so it's not quite working, but just a little bit of a high level. Unfortunately, the video is not working. It's supposed to show a row-based architecture versus a column-based architecture and how that flows differently. Little bit different. So row-based is obviously transactional, very much so for transactional use cases, for accounts, for updating different rows. Whereas column-based, yeah, apologies for that. The video does not work. I'll have to get back to you on the video that's not currently working there. But essentially the column-based architecture, you can see there with the columns in red, it's only ever going to use those columns. It doesn't need to scan every single column in the row. It just scans and it knows which particular column it needs because it's based in that file structure. So it knows which files to read. So apologies about the video there. Okay, so high level, ClickHouse, it speaks SQL. So it's standard SQL. So it's quite easy to use to get started. Everyone knows SQL. We're starting to see a lot of use cases. Me coming from a Splunk background, Splunk has its own language to write data or write queries, for example. Elastic has its own language. We're starting to see a lot of SQL for observability, which is quite good. So starting to use SQL for time series database. We're starting to see a lot of new functions that are being used for SQL database, for observability types use cases, not just transactional use cases. So standard SQL, lots of great functions in there. There's quite a few functions being released. It is open source. I think there was a new release that just came out this week as well with great new sort of functions, all based on SQL. So it can process heaps of writes, lots of writes, up to millions of rows per second, if not billions of rows per second, to be able to process that with a distributed scale-out architecture as well. So very big. I'm sure most of you have seen the power of ClickHouse and how it ingests data so quickly. So one thing I want to point out as well, which makes ClickHouse extremely popular, is the efficiency of the storage. And so because it's columnar-based storage, a lot of those files or a lot of the text within those columns are very similar. So it's quite easy to get good deduplication out of that data. So we see 10x type deduplication on top of ClickHouse, just being able to see the data in ClickHouse. So quite powerful from a storage efficiency there as well. And then obviously querying data, being able to run distributed queries across all the clusters is very powerful. So both insert queries, obviously, and select queries as well, being able to run that through. We had lots of questions about joins and lookups. We definitely want to do that. ClickHouse does do joins and lookups. It really comes down to how the structure of the file is written or how the query has been written. We'll go through some of that as well. Okay, so just to point out a few different customers and their different types of use cases. It is an analytical database. You can see that yeah, there's 3 or 4 main use cases. These are the top 3 that we tend to do. So user-facing analytics. If you're building a new application, if you're building a new website, if you're building a new widget, you want to provide user-facing analytics back to your customer. We see lots of those use cases within Clickhouse. That's definitely one of the big ones where you've got a lot of data and you want to share that data out with your customers. Very big in the telco space as well. Telco has a lot of rich data when it comes to RAN and sort of information tracking, location. All that sort of information is great if you want to present that back to your customer user, your end user as well. Internal analytics. So this is really replacing sort of the BI, internal BI that used to happen, the batch reports that used to occur. So all of the on-premise workloads that move to the cloud, a lot of those, almost like we call it like a data warehouse speed layer. So what that means is you might have a big data warehouse in the cloud. Eventually, you want to run real-time reports on top of that data warehouse. Sometimes it could be slow or expensive to run that on your data warehouse, whereas we see a lot of internal analytics where they offload that data from their warehouse into Clickhouse to provide that analytics and run those queries really fast and in real time. And also the big one is observability. Lots and lots of data and observability, whether it's NetFlow data or Cloudflare doing DNS logs or HTTP requests or 404 logs or telemetry data using OTel. Lots of use cases around time series data, lots of use cases around collecting logs, logging, and then creating real-time analytics on top of Clickhouse. Yeah, of course, we, as the CTO likes to say, we like to test against our competitor all the time. We have our own benchmarks. So we have ClickBench, which is our open source benchmarking tool that you can go and download. And ClickBench basically runs different types of queries and requests against all of the different databases that we know of. So there's heaps of databases like our Clickhouse. You can go in there and see all of the different results. ClickBench is actually an amazing tool. If you need to run a load test for your particular use case, you can quite easily import the data into Clickhouse, into that query, and then you can use that for performance testing to go and run how many concurrent queries you need to run. What is the average latency, the P90 latency, all those sort of things you can run with ClickBench. That's quite powerful. All right, so getting into creating a table. It's very similar to any other database. You will go through and create a table, customers in this particular case. You can see there's a whole bunch of sort of data type functions. Really, they all come down to sort of a few very common ones, but there's a lot of aliases to different types of data functions. But Clickhouse has some unique functions when it comes to low cardinality or arrays, for example, a map. These are all great functions to work with string type data. Low cardinalities, if you've got a lot of values that are sort of you want to group by and sort of create like a low cardinality of that value. It's a great use case for that. So heaps of really good use cases. There's things around working with JSON, XML, working with file integrations. Lots of great use cases there. The 2 things I want to touch on that makes Clickhouse a little bit different. The first one is the engine. So the engine in Clickhouse is what makes it so powerful. You can see there, it's called a merge tree. So what a merge tree engine is kind of nothing new. It's a log structured merge tree that's been around for a long time. However, Clickhouse makes it a little bit different. So as I mentioned earlier, every time you're inserting data, you're inserting columns, you're inserting a block of messages into Clickhouse. And that's called a merge tree. So what happens is every insert that you create will create its own block. That block will then get merged later on automatically within the system to create bigger blocks. And it's actually quite powerful to do that. That all happens in the back end. And as you keep inserting data, the more merges occur. And then obviously the more deduplication you get, the more more deduplication that you get and the more compression you get out of that as well. And the last thing I just want to touch on is the order by key and lots of questions around joins. So really a lot of the time the joins will come down to a couple of things. So with Clickhouse, the order by key is probably the most important sort of setting that you can have in Clickhouse. Think of it like a primary key, but it's across a sparse index, which basically means, essentially what that means is you don't have a row by row sort of primary key. you have a grouping of a primary key that is a pointer to a block within Clickhouse called a granule. So that order by key, basically the rule of thumb is the less blocks that your query has to run, the faster your search will be. And that's really it. It's as simple as that. It's how do I design my order by key so that there are less blocks for Clickhouse to go and look at, or your query to go and look at within Clickhouse. So it's based on the data. It's based on where is the lowest sort of cardinality filter that I have that I can use as the primary key. And that's something, that's a workshop within itself, and absolutely happy to deep dive into any of your use cases around that. So touching on a couple things. So Clickhouse, as I mentioned, has a merge tree engine. It's also got sort of, merge tree was the first engine to come out, but then there's other engines that have obviously evolved and been created based on different needs. So things like replacing merge tree, which will reduce duplicates as well. So it'll go through and reduce duplicates of data. Collapsing merge tree. I've got a question on this later. So collapsing merge tree allows you to update or delete or update fields within a record. So that's there. And then aggregating merge tree, great when you're using materialized views and things like that to aggregate data. So great, yeah, there's lots of good engines there. They're probably the top three. Integrations, someone mentioned ClickPipes. So ClickHouse Cloud has a product called ClickPipes, which has a whole range of integrations. At the moment, it's all Kafka based. So anything that uses Kafka protocol will have an integration in ClickPipes. And it's a streaming integration. It's not a batch request. It's constantly streaming data. It's a Kafka client, Kafka consumer that will go and interact with your MSK, your Confluent, or any other Kafka protocol type device and pull that data in. So lots of those integrations. There's obviously Postgres, MySQL. If you have nothing else, there's always the JDBC, ODBC connector that you can use as well. Okay. All right, so just wanted to touch on this point a little bit. So with ClickHouse, when you set data into ClickHouse, it's quite simple. Insert data, everything's an insert. All the inserts are, even the connectors are all inserts. But if you want to insert data, you just insert a normal set of data into ClickHouse. So I just want to insert some values. And this is really good. So by default, ClickHouse is a batch-based system. So as I mentioned earlier, you're creating lots of blocks. You're creating parts. You're creating lots of files on the file system. So by default, you don't want to insert row by row sort of messages into ClickHouse because it is a batch-based system. You want to insert millions of rows or hundreds of thousands or thousands of rows all in one big block so that merge tree can go and do what it needs to do to merge those blocks. Now, in saying that, ClickHouse also has a feature called asynchronous inserts, which is kind of a little bit different. So if you do want to insert smaller rows, you can turn on this feature called async inserts, which basically what it does is the row by rows or the smaller rows will be kept in memory in ClickHouse. So ClickHouse will keep all of the rows before it writes it to disk. I think it's 200 milliseconds or something like that. And then it will grab all of those rows and then it will create a block or a part automatically. So your application doesn't have to batch the data. ClickHouse will batch it for you and then write that into a file system. So that's absolutely quite powerful. Okay, and lastly, I just wanted to touch on, you don't even have to ingest data into ClickHouse. You can just read it directly from file or S3 or read it from MySQL directly and query that database. It probably won't be the fastest performance, but it works. I mean, you can go through, it'll infer the schemas, so it'll go and try and guess or determine what the schema type is. So you can just select from any of those integrations. Or you can obviously do an insert into select, as you can see there, where you want to read the file from S3 and then insert that into your ClickHouse table to make that more performant as well. So quite a few sort of integrations there. And a little bit of best practices. Now, as we know, ClickHouse is used for aggregating against lots and lots of data lots of data across a group of time. So typically in your production queries, you don't want to run select star. I mean, I do it all the time, but I'm not in production. But you don't want to do select star, all that sort of stuff. That's not going to be very performant. It's not really made to go and do a full table scan of the database and pull information back. And also, you don't want to go back and just go row by row, where you can just select one particular row that you're looking for. It's also not a very good, efficient way of doing that within ClickHouse. what you do want to do, and think about this from a file perspective. Imagine average something was a file within ClickHouse. So you want to get the averages of something between everything in 2022. That's where ClickHouse really sort of performs, is being able to create, a very fast average on top of everything in that file, that column-based file, for the year of 2022. That's a really good query to write. Okay, so there's, as we know, so we spoke about inserting data, how to get data into ClickHouse, and then some querying of data as well. So if you go and write a great query and you want to keep that query, you can save that as a view. And essentially, it's just a saved view. It's a saved query, so you don't have to rewrite it. You can share it, and then you can use that view again for later purpose. So it's great. But I guess the real sort of power and benefit to ClickHouse comes when you're using a materialized view. And let me talk about this in a little bit more detail. I know everybody in this room knows what a materialized view is, but in ClickHouse, it's a bit different. Traditionally, with materialized views, databases have this. It's almost like a batch process. You would almost schedule a cron job or something to go and create a materialized view and then create that materialized view. It's great, it works. You could use that to replicate data, that's fine. With ClickHouse, the way a materialized view is created, it's triggered on insert. And if you're not familiar, this is super powerful. So every time an insert is created, you run an insert, batch, the async insert, it's going to create a hash of that particular block. That hash is automatically going to be associated back to the materialized view, and it's going to trigger that materialized view in real time. So think about it. So going back to Kafka, right? So Kafka's got Kafka Streams, Flink, it's got KSQL DB. Think of materialized views almost like a real-time Kafka service, if you wanted to think of it that way. It doesn't, with Kafka, you still have to consume the data, then you have to aggregate it, then you have to write it back to a topic. ClickHouse, you don't have to do that. On the original insert, it's going to trigger the materialized view straight away without having to read or write or do anything. You don't have to, there's no deduplication of the data. It's just one process. So it's very powerful. And then as it does that, it also creates a summary, essentially an aggregating summary within ClickHouse in the materialized view that you can query super fast. So absolutely very powerful feature that we should be using. And just a little bit about the integrations. I won't spend too much time on this. I'm sure you've seen this, but ClickHouse has two main protocols, the HTTP native protocol as well. So you can use HTTP to correct data, or the native TCP protocol. Everything, we see a lot of Go, lots of Go integrations with ClickHouse. Is quite fast. So definitely Go and Python, we see that quite a bit. And then obviously ingest data from all of the different sources. ETL's a big thing as well. How do you make sure your data's in the right format? Ideally, you want to deduplicate the data before it gets into ClickHouse if you possibly can, and make sure you've got exactly once. You can do that in ClickHouse, but if you could do it in the application or in the pipeline, or if you don't have a pipeline, that's fine. But if you can, it's probably better to do those things in your ETL tools. And then things like vector for metrics and OpenTelemetry and those sorts of collections of those integrations there as well. So what does a ClickHouse architecture look like? A traditional architecture looks like this, where you can have multiple servers and shards that are split across, and it could be a big server. So the biggest one we've seen is 4,000 servers. You can have a table that is great for joins, example, if you want to have a table that's replicated across all of those 4 different servers, so you got a full copy of that. If you're doing a join table, you want to do that if it's high performance join. And then there's obviously where you've got shards and replicas of distributing that table out. So it just depends on the use case. Now, each ClickHouse server has to have its own disk associated with it. So you'll have your own physical disk that is applied to ClickHouse, the server. I just want to touch on the ClickHouse cloud architecture because it is fundamentally different, and it's getting a few more changes to this as well. So as you can see, there's really 2 sections. There's the data plane, which is where your application lives, and this is where all of the data lives within ClickHouse. And then you've got your control plane, which is basically where you go and run all of your management, your orchestration, all of your admin, your console, all that sort of stuff comes out of the control plane. when you look at ClickHouse Cloud, really it's fronted by proxies and load balancers and all that sort of stuff to make sure you get the right efficiencies to all the different brokers. Now, the key part around ClickHouse is obviously the object store piece as well around ClickHouse Cloud. So earlier I mentioned ClickHouse self-managed would have to have its own physical disk associated with it. Now, ClickHouse Cloud has taken that away, which provides a few extra benefits. So being able to have an S3 object store, meaning now you don't have to have dedicated servers to a physical disk. You can have ephemeral servers. You can have servers switched off. Actually, we do that. When the servers aren't being consumed for a while, they go idle and they turn off. So it's not consuming compute. And then they'll automatically turn back on when you need to use that service again. And this is all completely, the servers are completely ephemeral to be able to access that. So you can scale up, scale down, scale out, all that sort of stuff. All of those benefits come with the shared storage there as well. And I just want to touch on that. S3 is the caching layer, which S3 has its own sort of cache, but can be slow depending on the use case. It could be up to 1 or 2 seconds worth of latency for S3. So we've provided this intelligent cache layer that sits on top of the S3 object to make sure that the data is already cached in really fast sort of SSD drives to be able to access that data quickly. So typically it will warm or write to the cache on inserts by default, because usually the most current data is the one that you want to access straight away. So as you insert it, the cache gets warmed and it should be pretty fast. So. Okay, so any questions on that before I jump into a quiz? I wanted to do a little quiz, yes.
Hello, yeah, my name is Neeraj Morgal. So I have a question here, like we are using microservice-based architecture. So we have shown this this thing, how it connects, application connects. So where is that connection pool happening? I mean, we have different microservices and different databases all together. So though it is an anti-pattern in microservices that we can't connect, a single application cannot connect to multiple databases. But how ClickHouse manages connection pool? Is it fine to connect different databases in a single service via single service? I mean, because it's files in the end, right?
So if I understood that correctly, I think you're asking about if you've got multiple servers and you've got a single application, how does it know which server to read from?
Yeah, so each service has their own each ClickHouse database, each microservice. So is it fine that suppose the service 1 connects to the database of service 2 directly through connection? So is there any limit on connection pools or concurrent queries when doing that?
More like a session handling.
Session handling or concurrent queries.
So you can have a distributor table that obviously knows where all the data is. So if you're talking to the distributor table, then that distributor table will know which particular data that lives in. But typically the session would be handled by the application, maybe?
Yeah, so each microservice, can it connect to the database of other microservice, a ClickHouse DB?
I'm sorry, I can't.
You're not getting it.
I can't hear you properly now, I'm sorry.
Okay. Let me recreate. So there is a microservice and it has its own ClickHouse database.
Yeah.
Okay. Though it is ClickHouse cloud is same, but it has a different database. And there is another microservice which has a different database. So, but we want to merge that data in the end. So on the front end, the query should go that whatever data is here, it should merge with the other database, and then it should create one result of it.
Are they separate namespaces?
Yeah.
Okay, that's a little bit different, obviously. Yeah, so if they're running separate namespaces, it'll be a little bit difficult, obviously, to know. Obviously, you want to avoid deduplication. You want to avoid reading the message twice, all that sort of thing. If it's one big cluster and it's distributed across a multi-region, then you can hit the distributor table that will keep track of it. But if they're multiple namespaces, not multiple ClickHouse clusters, and your application needs to read from multiple, you can replicate data between the multiple clusters. So you can have cluster A, cluster B, cluster C.
It's single cluster as of now.
It's not synchronous replication at the moment. It's but in ClickHouse, it's asynchronous replication. It's more of a backup function than it is a high availability function. to replicate across multi-clusters.
Mm-hmm.
Yeah, so it's probably not. If you need to have an application that needs to talk to multi-regions
Mm-hmm.
and there's separate clusters, there's no synchronous way of doing that at the moment. Not within ClickHouse.
Got it.
Yeah.
Got it. Yeah.
I don't know if I answered that question correctly.
I have kind of. Maybe I can explain you in a break or something. We can do that.
Okay.
You can take more questions. Yeah. Thank you. Thank you.
We can chat after. Thank you. All right. Sorry. Not working? I was going to do a quick little quiz, but that's okay.
Hello, Johnny and everyone.
Yep.
Aman Manapure this side. Since you mentioned about ClickHouse Cloud, right? So is it something you go to ClickHouse website and then deploy this solution? Or is it like a vendor-based solution where you, let's say, deploy everything following a documentation since you mentioned EKS, GK, AKS, or it's like a marketplace offering on these cloud providers?
Yeah, it's actually a marketplace offering. You can just go to clickhouse.com and then you can just sign into cloud and pick GCP, AWS, and Azure's coming very soon as well, Microsoft Azure. But that all runs exactly like that, where you have your own control plane, and then the data plane will live within your service there as well. But you can run that any marketplace. So ClickHouse Cloud, get started for free, all those sort of things as well. So you don't have to host anything.
So basically, it's like ClickHouse license plus the vendor charges?
Sorry, say again?
So the costing would be the ClickHouse subscription or the license plus these vendor charges, cloud vendor charges, right?
Yeah, so all the costings on the website.
We currently use Druid.
Druid, yeah.
That's where we're also evaluating ClickHouse, and where I don't have to have local storage on the server. All my data is in S3. And having this in ClickHouse open source is going to be really helpful. And I believe there would be a lot of adoption as well.
Yep. So are you saying querying S3 directly or storing the data directly?
Querying S3 directly from ClickHouse without having to load or have storage on the ClickHouse servers.
Yeah.
Right now, you need to have storage, ephemeral storage on the ClickHouse servers, right? How about replacing that with AWS S3 or any other object store for that matter?
You can do that now. So there's S3 function where you can query directly from S3, but you still need to read from S3, which is not the fastest disk. So you can do that right now with ClickHouse.
Yeah, I still need to load from S3 and store it into ClickHouse, right?
You don't have to store it into ClickHouse. You can just query from S3 and you can run all of your dashboards and query from S3 directly. But it's not going to have the same performance, obviously, as storing it in S3.
Also, could you just a little bit about the order by?
Yep.
And I'll hand it over to others.
Okay.
Thanks.
So the order by, basically, ClickHouse stores, every time you create a new insert, there's no primary key. It's an order by, right? So the order by goes down to 8192 rows, I think it is. That's the minimal amount of rows. That's a logical sort of mark that ClickHouse creates to basically say, I want to order by a particular row, right? A particular key or column. So you're not looking through every single 8192 for a primary key. The mark knows the start and the end of that particular file. That's how powerful it is. So anything you're doing, like select star from S3 where, I don't know, date equals XYZ, then date is a good order by key to start off with. Anything with a where clause, typically you want it to be in your order by straight away. Yeah.
Yeah, hello. So
Hello.
my name is Paryu. So currently we are having a ClickHouse as a clustered setup with a 5 nodes and following distributed architecture with starting an application. So what my question is, in a configuration we define users, okay? So what's the difference between, like I want row level security. So let's say I have many tenants, okay? My company has many clients and I have created like different users for each client, okay? in the configuration. There are two ways to create users. So one is while creating a database, I can create a user configuration. Another is I can place the configuration in XML files and grant them default roles. Okay. So what difference does it make, and can I have row level security on the top of that? Let's say if I give directly configuration in XML files.
I think I got it. I think you were mentioning you want to insert data from a database, but how do you know which row
Yeah.
that's been?
Basically, I want user-based segregation on my cluster. Okay.
Yeah.
So there are two ways in documentation. One is I create user while creating a database and grant this privilege. Another way is I can provide user in the configuration. So I want users to be a part of a configuration. So how ClickHouse will know which to follow or what to follow, because there was no differentiation I got found in the documentation.
Yeah. Can we talk about this one after? Is that okay? That's a
Yeah.
bit harder.
And
Yeah. Thank you.
another use.
Thank you. Sorry.
Yeah, hello, one more question. Like recently, we've done some machine learning integrations with ClickHouse also, right? Like with MindsDB and stuff, where the models are pre-loaded into ClickHouse and queries can directly be run on machine learning models. So in the future, are you planning on supporting any more machine learning specific things to make the job of data scientist and easier?
So about, did you say supporting open source ClickHouse? Is that what the question was?
Yeah.
Like, so
Yeah.
ClickHouse support? Sorry.
Like what we want is currently, like in a MindsDB integration, we have to, like user has to give the query, and on top of the query, ClickHouse will create a AI table and will give the insights. What we want is, as per the current market standards, you throw our data and you want insights on the top of the data. So is there something which ClickHouse will provide in the future? Like with MindsDB, you have to query what exactly you want, what is the use case, and it will take around like 10 to 15 minutes for a query to run, and it will give the insights on the top of the data. But if I want insights on something, let's say I have data coming in millions of rows, and I want the insight that this product is popping up or this product is in the demand. So is there something called as real-time analytics which I can get using ML models or something similar to MindsDB integration?
So if you want to, I think I'm understanding. If you want to see the queries, the execution failures, all that sort of stuff, if you look in the system log, the ClickHouse, is that what you mean? So looking into the ClickHouse query system query log? No, not that. I think maybe I'll come catch up with you after. I'm just not hearing properly. That's all. Thank you.
Hi, Johnny.
Sorry.
I'm Swarnava. I am from a company called True Beacon, which is a hedge fund. So we have a use case where we're trying to use ClickHouse to aggregate our price data, right? Yeah, we are trying to aggregate our price data, and we're just in the POC stage, and where we are stuck sort of is trying to understand how to partition and use the order by correctly, considering that our data volumes are massive for a day, right? We have sub-second data populating our database, as well as how do we basically understand what size, is there a limit on the partition size that we should use to optimize it, and how to order a use case like this, right? Where you have just time series data and maybe a stock ticker, and you want to aggregate by, say, average price over a minute or 5 minutes or so on and so forth.
Yeah, it's a good question. Definitely look at, are you using materialized views? Materialized views? Are you using material? You are using them? Yeah, so absolutely, that's the best use case. With the query, how do you know which partition by? How do you know the query type, the speed? It takes a bit of time to understand the query, to see what the data looks like, to see the order by key. So typically we'll look into the system query logs, and we'll go through and look at that query, start to see if there's any type failures, look if there's how long the start time, the finish time takes to execute that query. We'll look at the query, and then we can go through and see what's the best optimization for that query. We also have, through Grafana, there is a ClickHouse plugin through Grafana. That's the one we use. Within there, there's there's 3 or 4 dashboards that you can import from Grafana as well directly. And then that will show you if you're having issues with, for example, the async inserts, if there's too many parts, if the mergers are taking too long, you'll be able to see all of that. A lot of those metrics are in the Grafana dashboards, and you can import them through the plugin, and you can start to see those operational sort of overheads. If there's anything to a particular table that is taking too long, like too many parts is a good one. There's also a really good article, which I'll share after this, called the 13 Deadly Sins of Clickhouse. We did a actually meetup on that in Singapore. It's probably a good meetup to do here next time, but it talks about some of the performance training you can do. Oh, thank you. Thank you.
Thanks, Johnny. Thank you so much. Great talk to start with, introducing ClickHouse. And I can see the interest in the audience. Absolutely loved it.
Thank you, everyone. Thank you.